Hey, what's going on, everybody? It's your boy Nin James 101 back here with another installment of Crayola's Corner. This video will specifically cover Polya and Polya's method, but what I want to dive into real quick is why I wanted to make this video. So the next videos that I'm going to give out as far as following along or problem solving functions, I'm going to say things out loud that kind of seem very baby step-ish. And I wanted to give some insight into why I'm doing that. So let me tackle that real quick. So if all you get from this is why I'm doing that, then you don't have to listen to the rest of this video. So when I solve any type of problem in coding, I like to break it down step by step. As the question continues to go over what it wants, like what it's asking, I'll lay out, hey, this is a function. It's passed this parameter. Oh, it needs to return this. I'll type all those things out. So when you follow along for my next set of videos for making functions or these foundation problems specifically, you know, okay, well, James isn't just crazy. He's following this method. So boom, there's the explanation. You can move on if you want. Second step, let's get into Polya and who he was. So first of all, take the time to Google George Polya. The dude was amazing. Look up his Wikipedia. The dude lived to be 100-something years old. He was a mathematics professor at Stanford. Just great dude. And through his time as a mathematics professor, he came up with this book called How to Solve It. And it's available online. You can go and read it. If you're a student, if you're a teacher, I suggest you read it. It gives fantastic methods from how to approach problems, from how to approach it from a teacher standpoint, from how to approach it as a student standpoint. As far as my exposure to Galvanise goes, I got exposed to it basically my second day in the class, specifically relating to problem solving. So the condensed version of Polya, which I'm going to break down step by step after I go through everything, Polya's problem solving techniques. The first one, understand the problem. The second one, devise a plan. The third one, carry out the plan. And the fourth one, look back. Now, all of these things seem fairly intuitive, but I'm going to break down each step so that you understand the depth in which you need to go. So, as developers or as humans, we're conditioned to see a problem and immediately try to solve it. That's just how you were brought up. That's just how the school has taught you. There's a very check-the-box mentality in modern day, or I guess, modern day education, which says, hey, solve for X. Hey, tell me what the bone right here is. You know, and so you memorize these things and you solve them enough insofar as it gets you to pass the test. But what Polya talked about was solving a problem for the sake of learning how to be a problem solver. What does that mean? Well, it means that if all you care about is getting to the end result, you'll never appreciate how you got there. So if someone says, hey, James, if I give you an array of numbers, I want you to return the greatest sum. I want you to return the greatest number in that array. The first thing that I'm going to do is going to start coding. I'm going to say, cool, I know how to do that. I'm going to write it out and I'm going to send it in. And you know what? You might be able to do that. You might have done it tons of times. You might just know the inherent principles of the question that you've been asked and send it out there. But what you aren't doing is you aren't taking the time to really appreciate what's happening as you solve the problem. And as a result, when other problems come up, you can no longer relate to how you solve that to new problems. So, what does that look like? Polya says that regardless of the problem, you have to first identify and understand the problem. So what is the problem? Well, I want to find the largest number in an array, right? And that step includes looking over the problem, repeating it back, understanding exactly what it's asking. It can seem very, it can be very painful and drawn out for this process, especially when it's something that you know, but it's worth putting the time in. Because when we solve this problem, the steps we took or the challenges we faced as we solved it can come back up in later problem-solving techniques. So, understand the problem. Cool. I want you to write a function that takes an array as a parameter of numbers and returns the largest number in that array. So, I understand that it wants me to write a function. I understand that my array will have numbers, and I understand that I need to retrieve the largest number in that array. I've broken down the problem, I've looked at it front and back, and I can repeat it back to you. Basically, in my own words, what this is asking me is, given any array of numbers, I need to give you the largest number. Boom, I can recite it back to you. So I have a firm grasp of what it wants me to do. Second step, devise a plan. Here's where a lot of people falter, where a lot of people kind of just go off on their own. In your head, whether you've seen it before or whether you have the knowledge to solve it, you just kind of jump right into it. You immediately start coding, which is fine. But taking the time to devise a plan and saying that, hey, cool, so I know that I need to write a function, so I'm going to go ahead and write the function. I'm going to call it largest num. I'm going to pass it a parameter of an array. And inside of those, inside the body of the function, I know that I need to loop through this array. Because for me, sorting through arrays, the best way I know how to do that is through a loop. So what I know I want to do is I want to loop through it. And I know that I want to pull out the greatest number. So in my head, I'm going to think to myself, hey, my plan is to get the greatest number. How are you going to do that? I'm going to create a loop. I'm going to make a conditional that checks each item in the array, compares it to another one. And if that one is greater, I'm going to take that, and I'm going to return that number. Cool. There's my plan. The third one is actually carrying out the plan. Now you'll notice that a lot of people, right, will have already laid all these steps out without really thinking about it. Execute the plan. Do you understand it, right? Do you understand all aspects of the problem? Have you devised a plan? Or have you just written code out? Have you just written a solution out? Carry out your plan. Enact it. Understand that in this part, right, where problems are more complex, more convoluted, carrying out the plan is probably one of the most crucial parts. Understand that parts of the question that you might not have understood become more clear here. If I carry out my plan, and one of my favorite things to do is say, if I do this, I expect this to happen, and it returns something that I didn't think to be true, I can say, cool, I carried out the plan. And comes a step 4, look back at it. This is the problem. This is how I expect to solve it. I'm going to carry out my plan. Oh, what I expected to happen when I carried out the plan did not actually happen. So I'm going to look back at it and I'm going to say, oh, here's a point that I didn't actually know. I didn't see that it needed to be an array of numbers. I didn't see that it needed to be a function. I didn't see that I needed to return this value. And you come back through and you hit all the steps over again. And Polya says that specific instance where you are trying to solve the problem is relatable to all things. If you say, my problem is that I'm hungry, I'm going to understand my problem. I'm going to devise a plan. I'm going to get up and I'm going to go fix myself a sandwich. I'm going to carry out the plan and I'm going to go fix the problem. Cool. I get to the fridge and I didn't take into account the fact that I'm only hungry for certain things. I didn't take into account the fact that my fridge might be empty. And so now I get to come back and evaluate my plan and fix it and come over. That idea or that action of problem solving can be related all the way through. Hey, so I might not understand every aspect of this question, but I remember a specific time where I had a problem and I needed to solve it, and these are the steps that I took. And as problems are prevented, you tackle questions the same way, you can find footholds there to start off, even if you had no idea what the question was asking. Hey, this is how the steps I would take to solve it. This is what I'm going to enact. I saw the problem, I devised the plan, I went out and executed the plan. It didn't work, but I remember trying to do that. So that's kind of the long-winded versions of Polya. Why I think it's important, it should be implicit in this guide. But also, if you just watch the beginning, you understand why I'm doing this. Polyas is so much in depth, and I really suggest everyone go read how to solve it. And I want everyone to kind of take away from the fact, problem solve for the simple fact of problem solving. Because when you do that, when you put that time in, when you put that mental effort in, you're going to remember that. And on top of that, you're going to be able to relate that specific instance to another problem you want to solve. And by doing that, those problem-solving techniques are only going to grow. Every experience you have with each different problem is only going to allow you to make more specific references to more complex problems and translate that into problem-solving ability.